Lesson 5, Graphs of Trigonometric Functions. The graph of a periodic function is a graph that repeats itself over a particular interval of its domain. So on this graph on the right, if I choose this as a starting point, and I trace the graph up to this point, the next section of the graph is the exact same shape repeated once more. The period is the interval required to complete one cycle, which is one repeated pattern of the graph. So our repeated pattern is this starting point up to this endpoint. So that's the shape that gets repeated over and over and over again. So the length from beginning to end is what we call the period. The midline is the average of the maximum and minimum values of the graph. The maximum is the highest our graph will ever reach. So this is the highest it ever goes, so that's going to be our maximum value. This is the lowest that our graph ever gets, so that's going to be our minimum value. So if you take the max plus the min and then divide it by 2, that's going to give us the location of our midline. So on this particular graph, the midline is this yellow line, and it's going to be the line that cuts our graph exactly in half. So it's going to be the same distance between the midline and the maximum, or the midline and the minimum. The amplitude of our graph is the positive distance from the midline to the maximum, or from the midline to the minimum. The amplitude can be calculated by taking the max, subtracting the min, and then dividing by 2. So on our graph, the amplitude is the distance from the midline up to the maximum, or from the midline down to the minimum. So either one of those is our amplitude. Example 1. Determine the period, midline, and amplitude for each of the following graphs. For A, to find my period, I'm going to pick a starting point. I like to start on the y-axis, so I'm going to pick that point there. And when I trace my graph, I want to make sure that I end that cycle at the exact same height as where I started. So I'm going to stop here. The distance in between those 2 points is going to be our period. So I started at an x value of 0, and I ended at an x value of 8. So the period is going to be the difference between those two values. So 8 minus 0 is going to give us 8. Now, you can find the period at any 2 points. So if I didn't use 0 and 8, and I wanted to start at this point instead, I just have to make sure that when I trace my graph, I end at the exact same height as where I started. So that means that I started at an x value of 2, and then I ended at an x value of 10. So if I wanted to calculate the period between my start and my end point, I just take those two numbers and find the difference. So 10 minus 2 still gives me a period of 8. So no matter where you start, as long as you end that cycle properly, you should always end up with the exact same period. Now for the midline, we have a formula. You're going to want to take the max value and then add the min, and then you'll divide that number by 2. So our maximum is the highest our graph ever goes. So in this case, our maximum is going to be 10. And our minimum is the lowest our graph ever reaches, which in this case is a minimum of negative 10. So then if I plug in our max and min, I've got 10 plus negative 10, and then divided by 2. Now, if you're going to put this in your calculator right away, make sure that you have brackets around the top. So then 10 plus negative 10 is going to give us 0, and 0 divided by 2 is going to give us a midline of 0. So when you write your midline, you're going to write it as an equation of y is equal to 0. And on our graph, it's just going to be the line that sits right on top of the x-axis. And that line is going to cut our graph exactly in half. Lastly, we're going to find the amplitude. And we've got a formula for that as well, but it's going to be the max minus the min, and then divided by 2. So our max is 10. We're going to subtract a negative 10. And then if I divide that by 2, I'm going to want to put brackets around the numerator again. 10 minus a negative 10 gives us 20, and 20 divided by 2 gives us an amplitude of 10. So the amplitude is just the distance between the midline and the maximum, or the midline, and the minimum. So each of those heights is going to be an amplitude of 10. For B, to find my period, I'm just going to start at this point, so starting on the y-axis. And the reason why I do that is because on the y-axis, our x value is equal to 0. So that just makes our starting point a little easier to work with. Now I'm going to trace my graph and make sure that I end that cycle at the exact same height as where I started, which is going to be this point right here. And my end point is going to be x is equal to 6. So if I wanted to find the period, I'm just going to take 6 minus 0, which is going to give us a period of 6. To find my midline, I'm going to need a maximum. So the highest our graph is ever going to reach is 6, and the lowest our graph ever reaches is a minimum of -2. So then if I plug those in my formula, I'm going to have 6 plus -2. And then if I divide that by 2, I'm going to get a midline of 2. So if I write my equation as y is equal to 2, our midline is going to be located at a y value of 2, so it's just going to be a horizontal line all the way across. Okay, and that's going to be the line that cuts our graph exactly in half. For the amplitude, I'm going to take the max minus the min, so 6 minus -2, and then divide that by 2. So 6 minus -2 is 8. 8 divided by 2 gives me 4. So that means that the distance from the maximum to the midline is an amplitude of 4. But from the midline down to the minimum is also an amplitude of 4. In the next section, we're going to take a look at the graphs of sine, cos, and tan. But first, let's start with sine. So we're going to graph y is equal to sine of x, create a table of values, and then draw our graph. So first, make sure that your calculator is in degree mode. And in y1, we're going to input sine of x. For our window settings, make your x min 0, x max 360, your y min -2, and your y max +2. When you hit graph, you're going to see a S-shaped curve that looks like this. And to figure out our table of values, you're going to press second, trace, and then choose option number 1 for value. And when it prompts you for an x, type in x is equal to 0. And then if you press enter, you're going to get y is equal to 0. So in our table, for 0 degrees, we get sine of x is equal to 0. And then you're going to do that again. Second, trace, and then value. Next time it prompts you for an x, type in 30. And if you press enter, you get y is equal to 0.5. If you go second, trace, and value, and then put in x is equal to 90, then we get y is equal to 1. And if you continue in that fashion, 150 will give us 0.5, 180 will give us 0, 210 will give us -0.5, 270 will give us -1, and 360 will give us -0.5, and 360 gives us 0. To plot our graph, we're going to treat the x and the sine of x as our x and y values respectively. So for 0 degrees and 0, we get the coordinate 0, 0. So that would be this point right here. And then the next point would be an x value of 30 and a y value of 0.5. So on our y-axis, if this is 0 and this is 1, halfway, so 3 squares up, that's going to be 0.5. And 3 squares down from the x-axis is going to be -0.5. On our x-axis, we've got 90 degrees, 180, 270, and 360. So 90 degrees is 3 squares, which means that each of these smaller squares, if I divide that into 3, is going up by 30 degrees. So my next coordinate is 30 and 0.5, which means that I have this point right here. Our next coordinate is going to be 90 degrees, 1. So 90 and 1 is going to be right here. The next coordinate would be 150, 0.5. So 150 is going to be right here on our x-axis, and we're going to have a value of 0.5. So our point lands right there. 180 degrees will give us a y value of 0. So that means that we're going to be right on top of our x-axis. Our next point is 210 and -0.5. So that's going to be right here. And 270 and -1 is going to be down here. 330 and -0.5 will be here. And the last point, 360 and 0 is going to be right on top of our x-axis. Now, if I connect to all those dots, I'm going to get the graph of sine of x. And this represents one full cycle of sine of x. So to find our period, our starting point is 0 and our end point is 360. So the distance in between those 2 points is going to give us our period. So if I took 360 minus 0, I get 360 degrees. So that means that the period of sine of x is 360. For our amplitude, normally the formula is max minus min and then divided by 2. So our max in this case is a max of 1. And our minimum, the lowest our graph ever goes, is a value of -1. So if I took 1 minus -1 and then divided it by 2, again, putting brackets around the numerator, 1 minus -1 gives us 2. 2 divided by 2 gives us 1. So the amplitude is equal to 1, which means that the distance between our midline and our maximum, or the midline and our minimum, is just a height of 1. To calculate the midline, we're going to take the max and then add the min and then divide it by 2. So we're going to take 1 plus -1 and then divide it by 2. That's going to give us a midline of 0. So the line y is equal to 0, which is right on top of our x-axis, is going to be our midline, which cuts our graph exactly in half. Now, to find our domain and range, because this is a periodic function, if you continued this graph, it would take the graph of sine of x that we have from 0 to 360, and it's just going to be repeated over and over again towards the right. So if it kept going, it would just be the same shape, just continuously going forwards towards the right, and it would be the exact same shape towards the left as well. So for our domain, the graph is going to go left forever, and it's going to go right forever. So for our domain, we're just going to write that x is any element of the real number system. And the other way that you can write it using set notation is round bracket, -infinity, comma, +infinity, and then a round bracket. For our range, our graph only lies in between our maximum and our minimum. So that means that our y values are always going to be either greater than or equal to our minimum, which is -1, or less than or equal to our maximum, which in this case is +1. And in set notation, we would write square bracket, -1, comma, +1 square bracket. For the x-intercepts, we have multiple times that the graph crosses the x-axis, so we're just going to record the ones that we see on one period of our graph. So it hits the x-axis once at 0 degrees. It hits the x-axis again at 180 degrees. And it hits the graph again at 360 degrees. Now for our y-intercept, the only time that it touches the y-axis is at the point 0, 0. So that means that our y-intercept is going to be either written as 0, 0, or you can write y is equal to 0. Now we're going to look at the cosine function. So we'll do the same thing. We're going to graph cos of x, build a table of values, and then use that to plot our graph. So first thing, again, make sure that you are still in degree mode. And then in y1, graph cosine of x. We're going to keep our window settings exactly the same. So x min is 0, x max is 360, y min is -2, and y max is 2. So once you hit graph, this is what you're going to see. And to fill out our table of values, we're going to do the same thing as we did with sine, and press second, trace, and choose option number 1 for value. And when it prompts you for an x value, we're going to type in x is equal to 0 first, and you're going to get a y value of 1. So that means in our table, for 0 degrees, cosine of x is equal to 1. Then we'll do second trace value and then input x is equal to 60, which gives us a y value of 0.5. And continuing on in that pattern, 90 degrees is 0, 120 degrees is negative 0.5, 180 is negative 1, 240 is negative 0.5, 270 is equal to 0, 300 is equal to 0.5, and 360 is equal to 1. We have the same x-axis and y-axis. So on the y-axis, this point will be 0.5. This point will be negative 0.5. And then each of the squares on the x-axis equals 30 degrees. So for the first point, we're going to graph 0, 1. So 0 for the x, y for the 1, 1 for the y. So we have our starting point right here. And then at 60 degrees, we've got a height of 0.5. At 90, we are at a height of 0. At 120, we are at a height of negative 0.5. 180 is negative 1. 240 is negative 0.5. 270 is 0. 300 is 0.5. And 360 is equal to 1. We're going to connect those dots and create our cosine curve. So you can see it has a bit of a cup shape. To calculate our period, our graph starts at an x value of 0 and it ends at 360. So to measure our period, we're going to take the difference between 360 and 0, which means that our period is equal to 360 degrees. For the amplitude, we're going to use the formula max minus min divided by 2. Our max is positive 1, and our min is equal to negative 1. So we're going to have 1 minus negative 1, and then divided by 2. And we'll put the top in brackets. 1 minus a negative 1 equals 2. 2 divided by 2 equals an amplitude of 1. For our midline, we're going to take the formula max plus min and then divide by 2. So we're going to have 1 plus negative 1 and then divide that by 2. And that will give us a midline of 0. So the line y is equal to 0, which lies right on top of the x-axis, is going to act as our midline. For our domain, the graph is going to keep continuing in this cup-shaped pattern. So as it moves towards the right, it's just going to keep following that pattern of that graph. And along the left side, it will follow the same sort of cup shape. So again, our domain is going to be x as an element of the reals. In set notation, that would be round bracket, negative infinity, comma, infinity, round bracket. And then for our range, just like with sine, our graph is always in between a maximum of 1 and a minimum of negative 1. So we want to say that all of our y values are going to be greater than or equal to negative 1 or less than positive 1. And in set notation, it would be square bracket, negative 1, comma, 1, square bracket. Now for our x-intercepts, every time the graph hits the x-axis is an x-intercept. So on this particular graph, just for the one period of cosine, we're going to hit the x-axis at 90 degrees and at 270 degrees. So we're just going to consider one cycle. So 90 degrees and 270 degrees. Now for the y-intercept, this time the graph is going to cross the y-axis at the point 0, 1. Or you can write y is equal to 1 as your y-intercept. Lastly, we are going to graph the tan function. So in y1, we're going to graph tan of x. You can keep your window settings exactly the same. And when you graph the function, you get something looking like this. To fill out our table of values, you're going to go second, trace, and then 1 for value. And when you're prompted for an x value, you can input 0, and then the next time you do it, 45, and so on. So when you input x is equal to 0, we get y is equal to 0. When you input x is equal to 45, then you're going to get a y value of 1. When you input x is equal to 90, you're going to get y is equal to blank. So we're going to write undefined for now. And for 135, you're going to get negative 1. For 180, you're going to get 0. 225 will give you 1. And 270 will give you y is equal to blank again. So for now, we're just going to write undefined. At 315, you're going to get negative 1. and 360, you are going to get 0. Now, when we're graphing, any spot that you get undefined, what you actually see on your graph is a vertical asymptote. So at 90 degrees, you're going to get a dotted line, which acts as the vertical asymptote. And as it goes down, it's going to cut 90 on the way down. And same thing with 270. Now, our asymptotes are 6 squares apart. So every 6 squares, you're actually going to get a vertical asymptote. So on the right side, if I count 6 squares towards the right, I'm just going to draw another vertical asymptote. And then on the left side, you're also going to get another vertical asymptote, 6 squares to the left of the 90-degree one. Now let's plot our points. So our first one is 0, 0. So that's just going to be on our origin. Okay, 45 degrees is equal to a y value of 1. So we get the point 45 and 1. 45 is going to be in between 0 and 90 degrees, and 1 is going to be here on our y-axis. So our coordinate point is going to be located right here. 90 degrees gives us that vertical asymptote. 135 degrees is a y value of -1. So 135 is in between 90 and 180, and -1 is going to be this height here. So our point is going to lie right there. And then for 180 degrees, we have 0. For 225, we have +1. So it's going to be right in between 180 and 270. 270 gives us that vertical asymptote. 315 is -1. So 315 is in between 270 and 360. So we're going to have this point right here. 360 is equal to 0. So we'll have a point right on the x-axis. And I'm just going to follow this pattern. So for the next point after 360, it's going to be right in between 360 and our vertical asymptote. So we're going to get a point right here just to match this guy. And on the far left side, we've got 2 points already, but I'm just going to draw another one in between 0 and our leftmost x-intercept, and it's going to have the same height as this point here. So in between each of our vertical asymptotes, we'll get these same 3 dots. So now when we connect our dots together, what you're going to get is this sort of S-shaped curve, so the stretched out S. So right in the middle, let's connect these 3 dots first. So there's going to be a slight little bend in the middle, in between these 3 dots. And then as we move towards the left vertical asymptote, our graph is going to approach the asymptote, but then it's going to shoot down into -infinity. And then as it goes towards the right, it's going to approach the asymptote. However, it's just going to shoot up towards infinity. And that's what's going to happen in between each of the asymptotes. So same thing with the 3 dots on the far left. So I'm going to connect them with a slight little bend. And then along the left side, it's going to shoot down as it approaches the left vertical asymptote. And then on the right, it's going to shoot up towards infinity as it approaches the right asymptote. And the same thing with the 3 dots on the far right. We'll connect them with a slight little bend in the middle. Along the left side, it's going to shoot down into -infinity. And then along the right side, it's going to shoot up into +infinity. Now, for tan, one cycle is going to be the sections in between each of the vertical asymptotes. So if I just look at the one in the middle, our starting point is going to be 90 degrees on the x-axis, and our endpoint is 270 degrees. So if I wanted to calculate the period, I'm just going to take 270 minus 90, which gives us a period of 180 degrees. So tan is different from sine and cosine because its period is half of sine and cosines, being only 180 degrees. Now for the amplitude, we're going to need the max minus min and then divided by 2. However, tan is a little special. Tan, because it goes up to infinity, we don't actually have a max. And then same on the left side, it goes down to -infinity. So we actually don't have a minimum either. So for amplitude, we're just going to write none. And it's going to be the same case with the midline. Since we don't have a max or min, you can't take max plus min and then divide by 2. So in this case, we're also just going to write none. Now for our domain, the same shape of our tan curve is just going to repeat forever on the right and forever on the left. However, there are certain points on the x-axis where our graph does not exist, and those are where our asymptotes are. So anywhere that there's an asymptote, okay, our graphs do not exist, which means that for our domain, we basically want to say x cannot be equal to any spot that has a vertical asymptote. So let's say x can't be equal to 90 degrees, x can't be equal to 270 degrees, and so on. However, if we want to write a general statement just to account for every single one of our vertical asymptotes, what we can do is we can write x cannot be equal to 90 degrees. So that gives us a starting point. So we are starting on this vertical asymptote, and our vertical asymptotes are always going to be 180 degrees apart. So if I want to say our domain is going to be non-existent at 90 degrees, and then every 180 degrees to the right and then towards the left, we say x cannot be equal to 90, and we can write plus 180 degrees times n. And if we make n be any integer, it's going to account for any vertical asymptote on the left side and any future asymptote on the right side. Okay, so this is how you're going to write a general statement to account for all of those asymptotes. For the range, because our graph goes down towards infinity forever, negative infinity, and then it goes up towards infinity forever, we can just write that y can be any real number. So as set notation, we'll have round bracket, negative infinity, comma, infinity, round bracket. For our x-intercepts, let's just state the ones that we can see. So I've got 1 at 0, I've got 1 at 180, I've got 1 at 360. So let's just list the ones that we see. So 0 degrees, 180 degrees, and 360 degrees. And for our y-intercept, the y-intercept only crosses at the point 0, 0. Earlier, we looked at the graphs of y is equal to sine of x and y is equal to cosine of x. So for sine, if I draw my x and y axis, one period of sine will have a starting point at 0, 0, and we've got our max at 1 and our min at negative 1. So from our starting point at 0, 0, the graph of sine is going to go up to the maximum, and then down to the minimum, and then right back up to that midline. And then for cosine, our graph has a maximum of 1, a min of negative 1. However, for cosine, our starting point for our period is going to start at the maximum, and then it's going to go down to our minimum, and then right back up to our maximum again. So sine and cosine have the same shaped graph. However, cosine is just shifted a little bit. Now, when we're transforming our graphs, you can apply the a, b, and c, and d values to each of the sine or cosine functions. And each one of those variables does something different. A is vertically stretching our graph. It also tells us what the amplitude of our graph is. The b value acts as the horizontal stretch, and that is going to affect the period of our graph. So we've got two formulas. The period, if you're working in radians, the period is going to be 2 pi divided by our b value. Now, if you're working in degrees, then the period is just equal to 360 degrees divided by b. Now, if you rearrange the formula, if you want to solve for b instead, then in radians, b is going to be equal to 2 pi divided by the period. But if you're working in degrees, the b value would just be 360 degrees divided by the period. The c value is going to be a horizontal translation. So that is going to shift our graph either left or right. And the d value, that's going to give us a vertical displacement, or it just tells us what the midline is. So the d value is going to tell us if the graph shifts up or down, and then it automatically also just tells us what the midline of our sine or cosine functions are. Example 2. Determine the characteristics of the graph y is equal to 2 sine times 1/2 times x minus pi over 3 minus 1. And then we'll use that information to sketch the graph on the grid below. So first, let's identify our variables. So our a value is the coefficient of sine. So a is going to be equal to 2 in this case. Our b value is going to be inside of our function, and it's going to be the 1/2. Our c value is going to be inside the brackets inside our function. So the x minus pi over 3 tells us our c value. And for this one, if you see x minus pi over 3, that means our c value is actually a positive pi over 3. And then our d value is the constant at the back, which in this case is equal to -1. Now to find our amplitude, amplitude is related to our a value. So if I know that a is equal to 2, then I automatically know that amplitude is equal to 2. To find your period, so this is related to our b value, but to calculate the period, you're going to have to use the formula 2 pi divided by b. So if I took 2 pi and then divided it by 1/2, if I wrote it like this, this is going to be equal to 2 pi times the reciprocal of 1/2, which is 2 over 1. So 2 pi times 2 over 1 is just going to give us 4 pi. So that means our period, the length of one cycle, is going to be equal to 4 pi. Our phase shift is pi over 3, and since it's positive, that means that our phase shift is going to be pi by 3 units to the right. So the phase shift is always related to the c value. And our midline is related to our d value. So if the d value is equal to -1, then our midline is automatically y is equal to -1. So amplitude, midline, and phase shift, you just take the numbers as is. The period, however, you do have to apply the formula 2 pi over b to get your correct period. Now for the maximum and the minimum, we have formulas for these. The maximum is just your d value plus your a value. So if you started at your midline and then you added your amplitude, that's going to give you your max, which in this case is going to be equal to -1 plus 2. So our midline is going to be, a maximum is going to be equal to +1. And then our minimum, the formula is going to be our midline minus our amplitude. So if I took -1 and then I subtracted 2, then I get a minimum value of -3. For the domain and range, we'll save those for after we've drawn our graph. So on our grid, let's mark off some points on our y-axis. So that would be 1, 2, 3, and then 4. And then below the x-axis, I've got -1, -2, -3, -4. Let's mark off our max and our min next. So our max, our graph never goes higher than a +1. So that's going to be our max. And our min, the graph never goes lower than -3. And we're also going to draw our midline. So if our midline is y is equal to -1, then at a y value of -1, we're going to draw a horizontal dotted line all the way across. And this is going to act as our midline, which has the equation y is equal to -1. Now, to draw our sine curve, normally sine of x looks like this, where if our midline is the x-axis, our sine curve starts on the y-axis on our midline, and then we go up to our maximum and then down to our minimum and then right back up to our midline. However, because we have a phase shift of pi by 3 units towards the right, what we're going to do is let's mark off pi over 3 here on our x-axis. So we're shifting everything over to our right. So if our starting point normally starts at 0, shifting it towards the right is just going to shift our starting point to be right here. So it's going to be on our midline at an x value of pi over 3. So that's going to act as the same point as our starting point on sine of x. Okay, and then from there, our graph has to go up towards the maximum. So from here, I'm just going to draw a bump up to the maximum of 1. And then from there, it comes back down to our midline. And then it'll go down to our minimum, which in this case is -3. And then once it hits that minimum, it's going to come right back up to our midline. So this is what the graph is going to look like with that phase shift of pi by 3 units towards the right. It's this exact same shape as sine of x. However, everything just gets moved towards the right pi by 3 units. So that's just one cycle of our graph. If we kept drawing it, it would just be the same shape repeated over and over and over again towards the right. And it'd be the same shape repeated over and over again towards the left. So then for our domain, what we can do is just write that x can be any real number, or as set notation, round bracket, negative infinity, comma, infinity, and round bracket. For our range, we're always going to be in between a max of +1 and a min of -3. So we'll just say that our y values are going to either be greater than or equal to -3 or less than or equal to +1. And as set notation, we've got square bracket, -3, comma, 1, square bracket. Okay, and the last thing that we're going to do is just label that one cycle of our graph has a period of 4 pi units. So from the starting point of our cycle to the end point of our cycle, it would just be a length of 4 pi. Example 3. Determine the characteristics of the graph of y is equal to 1/2 times cos of 3x plus 90 degrees plus 2. So first thing we actually have to do is inside the function, we've got this 3x plus 90. We actually have to factor out this 3 just so that we can split up our b and our c values. So if I rewrite it over here, I've got y is equal to 1/2 and times cos. And inside the function, we're going to factor out a 3, which means that we're just dividing 3x and 90 by 3. So you're going to get cos of 3 times x plus 30 degrees. And then our d value at the back stays as a +2. So our a value is going to be equal to 1/2. Our b value is equal to 3. Our c value is equal to -30 degrees because it's x plus 30 inside the function. And our d value is equal to 2. Amplitude is related to our a value. And if amplitude is equal to 1/2, then your amplitude is 1/2. Or you can write 0.5. For the period, since I'm working in degrees, I'm going to take the formula 360 divided by b to get my period. So if I took 360 degrees divided by 3, that means the period is equal to 120 degrees. Our phase shift is related to our c value. So if c is -30, that means that we're going 30 degrees towards the left. So we're shifting everything left. Our d value is related to the midline. So if our d value is equal to 2, our midline is the equation y is equal to 2. The maximum, we're going to use the formula d plus a to get our maximum. So we're going to go 2 plus 0.5, and that's going to give us a maximum of 2.5. For the minimum, we're going to go d minus a. So it's going to be 2 minus 0.5, which is going to give us a minimum of 1.5. Okay, and we'll save the domain and range for after we have drawn our graphs. So on our grid, let's mark off 1, 2, and 3 above the x-axis, and below the x-axis, -1, -2, -3. Our midline is y is equal to 2, so I'm going to draw that. At a y value of 2, just a horizontal line going all the way across. Our maximum is 2.5, so in between 2 and 3. This is the highest our graph is ever going to go. And our minimum is 1.5, so right here is the lowest our graph is ever going to go. Now, the graph of cosine. If I have my maximum here and my minimum down here, cosine is going to start at our maximum, and then it's going to go down towards our minimum, and then right back up to our maximum. So that's what one cycle of cosine would look like. Now, we also have to keep in mind that our graph is shifting 30 degrees towards the left. So let's say that we're going to move everything towards the left, -30 degrees. So our starting point is going to start at our maximum and left 30 degrees. So our maximum is going to be right here, okay, where our x value is also equal to -30 degrees. And from there, you're going to draw your graph so that it goes down to our minimum of 1.5, and then it's going to come right back up again to our maximum. So that's what one period of this graph would look like. So if it's the period going from the leftmost point of our starting point to the rightmost, that's going to be a period of 120 degrees. And the rest of the graph is just going to be the same shape, just repeated over and over and over again. So towards the right forever, and then it's just going to go towards the left forever. Okay, so for our domain, since it goes left forever and right forever, we'll just write XER, or in set notation, round bracket, negative, infinity, comma, infinity, round bracket. And then for our range, because our graph is always going to be in between our max and our min, we can say that our y values are always going to be greater than or equal to 1.5 or less than or equal to 2.5. And then in set notation, square bracket, 1.5, comma, 2.5, square bracket.